Hi everyone, the section 3.1, the binomial regression model. So I will discuss the model and also sample data. So first, a sample data. Now this is the O-rings data for Space Shuttle. So the Space Shuttle, the Challenger, failed in 1986, and that is caused by the failure of the O-rings. And actually, we have the 23 observations of Space Shuttle launch, and we have data for the damage to O-rings. And each shuttle has the 6 O-rings, and depending on temperature, some of the O-rings will be damaged. And this is the data. We have 23 observations, 2 variables, the temperature and the damage. So temperature is just numeric variable. And the damage is actually the count data, but this is out of 6 observations. So this means this says 5, 1, 1, 1, 0, 0, 0. But this actually means the 5 out of 6 and 1 out of 6. And 1 out of 6 and 0 out of 6 and so on. So this is basically a logistic regression, but the data is put in slightly different way. So the format for the GLM, Generalized Linear Model for Logistic Regression, family binomial, is this. So the response variable that should consist of 2 vectors. The first one is the number of success, and the second one is the number of failure. So it's slightly different from binary case. Then the same thing is for, the predictor is the same as usual logistic regression, so just temperature, and we specify data. Yeah, so once you fit the regression, then you can get the coefficient. So the coefficient of, this is the intercept and the coefficient. So this is a vector with 2 elements, so 2-dimensional vector. Of the beta naught hat and beta 1 hat. So so we have a plot. Okay, so we have the data of 23 data points here. You can see the higher the lower the probability of failure, the failed O-rings. And if you wanna fit some line, fit some curve by logistic regression, then you have to use the inverse logit function. So inverse logit function is power eta over 1 plus e to the power eta. And this eta is any number, but the inverse logit of the eta is between 0 and 1. And we have to put the predicted value, so eta value, inside this function. So the coefficient, the intercept plus the beta 1 hat times x, then we transform by logit function. Then we use the lines function. Then we can we can draw this fitted curve. Or if you wanna calculate the predicted probability for, the predicted probability for specific, actually the accident happened when the temperature is 31 degrees in Celsius in Fahrenheit in January. So in this case, actually, the failure probability is 0.99, so 99%, more than 99%. So that's the reason that the Space Shuttle failed. Yeah, so this is the data description. And what's the model that we used to fit the data? So that is basically the same as logistic regression, but only the difference is that the probability. So in logistic regression, we model the probability of yi is equal to 1. But here we observe the several numbers. So 6 out of, so the observations that we have 6 trials and the number of success or failure. So that is the response variable. So here, the left-hand side is probability of yi is equal to some number. So this is, in our case, the 0 to 6. The possibilities are 0 to 6. And the probability is formulated as this quantity. And the first one is the mi choose yi. So sometimes mi c yi, we say. So mi choose yi. So basically, this is the number of ways, the number of combinations to choose the yi objects out of mi objects. For example, the 6 choose 5, that we have the 6 possibilities, and so on. And yeah, so to be exact, this is the mi factorial over yi factorial times mi minus yi factorial. I choose yi, and the other part are the same. So if the so yi is basically, statistically speaking, the number of success. So in our specific example, the failure of O-ring is called success. But anyway, so for success, we have the success, then we have to multiply the probability pi. And if we have failure, we have to multiply probability 1 minus pi. So the likelihood is this, that if all events are independent and all events have success probability of p sub I, then we should have this. So actually, this is based on the IID assumption on these MI trials. So in our case, the M sub I is 6 for all observations. And other settings are the same as logistic regression. So the fitted value, the PI, is the inverse logit function of eta I, and eta I is linear combination of predictor variables. Yep. So this is the model, and estimation is the same. So we use the maximum likelihood estimator, and so we maximize the log likelihood. So maximizer of the L of beta is the beta hat. And the beta hat, we have another term, and we have several observations. So yi and mi. So this isn't necessarily 1 or 0. Mi is 6 in our case, and the yi may be 0 to 6, depending on data points. So it's slightly different, but the principle is the same as logistic regression in chapter 2.